Hey, welcome back to my channel and to a new algorithm challenge. Today's challenge is jumping on the clouds revisited. The success rate is 96%, so it should be relatively easy, hopefully. Erith is playing a cloud hopping game. In this game, there are sequentially numbered clouds that can be thunderheads or cumulus clouds. Her character must jump from cloud to cloud until it reaches the start again. To play Erith is given an area of clouds, C, and an energy level of E 100. She starts from index 0 and uses 1 unit of energy to make a jump of size K. Okay, to cloud next index modulo N. If Erith lands on a thundercloud, which is indicated by 1, her energy decreases by 2 additional units. Additional to 1 because of the jump itself. The game ends when Erith lands back on cloud 0. Okay, determine the final value of E after the game ends, so basically her energy level. We have clouds 1, 2, 3, 4, and then 1 has the 1, which means this is a thundercloud, and we're jumping, we have 2 in jumping distance, which means 1 jump, second jump to start, to be back at the start, and we have 2 jumps is 2 energy plus a thundercloud additional 2, which is 4 energy, which is we are losing, so we should have 96, final energy level 96. Okay, I think we understood how it works, and now it serves to make the route circular. If Erith is at n-1 and jumps 1, she will arrive at 0. Yeah. Okay, let's get to it. Basically, position is, okay, I would say while P is unequal 0, we want to, I think P in the end is gonna be P plus K modulo C dot count, because we have like 0 plus, say, a jump size of 2, which means, okay, we're jumping to 2 out of 4, which means 2 divided by 4 is 0 with a leftover of 2, which maintains our position. Same happens with 3, maintains our position, but at 4, right, that would mean it's the same count, so we're back at 0. And then this will stop. Okay, so that should be what we want to do after every while. Now, when we are here and we have, we start at 0, right? So this is our first jump. We already know that our energy level is 100. So we already are decreasing our energy level by 1. And then now we want to see if new position, the new position has a 1, right? So I'm thinking right now, if I would say, oh, if C at index P equals 1, then decrease E by another 2. However, we don't want to do that for the first position, right? Because what if that already is back to 0? So let's just say P unequals 0, only then. Right? Okay, let's see if that one actually is the result. Compilation error. Oh, whoops. We need here a spacing. Okay, no response. Then, okay, expected output 92. We got no response. Oh, wait a second. What if we want to say, oh, we want to do that already here. Yeah, we want to do that already here. And then we want to reassign, because that's our new position already. Okay, that's great. That should be better. Still something wrong. And I wonder what P is. We can print P. I think we can print P, and then we might have an index out of bounds exception. We don't see anything. Interesting. runtime error. Runtime error. What if we say p plus k, just like that, and if p equals is bigger than c.count, we say p equals 0. Actually, at least we have an output. Okay, so we have something wrong in our calculation. Because we say p equals k, we should be starting at 99, I think, because we are basically taking away that first jump already. Okay, yeah, of course it solved this one where we knew we were off by 1. This is the wrong answer. Should be, whoa! Oh, so it really loops over up until it's... Okay, so that's wrong here. We don't want to do that. If it's bigger, then we want to say p is a.count minus p, the difference. That's our new index. So let's say we are at 11. Yeah, so then it's the count. I was thinking whether it's count or count minus 1. I think that's hopefully the solution. A.count minus, whoops, why is it a C? Of course. Still, my output is 96 for some reason. So we should say P plus that. Let's print our, okay, let's print our P right here. And see what happens. Okay, let's see, we have minus 2. How? If P is bigger, oh, then we want to say, oops, that's the wrong way around, obviously. Yeah, yeah, so okay, that's the thing. There we go. Remove the print statement, we don't need this anymore. 82, damn, too close. I think we are missing the final jump to 0. If this one equals 1, we want to say e minus 2 as well. So let's see. Great, because we landed in the end on a thundercloud. Submit the code. What? Runtime error? No! Damn. Why? Let's unlock and see. What do we have here? Expected output 95. Well, it's a runtime error. Something is wrong. I wonder if we can print at least... Oh, we don't need to print it. The input is 1919. Okay, okay. We can accommodate this error actually already. We could say if P is equal to c.count, then, and then only else, we're gonna do the while, right? Then we can say, let's put this on the next line like this, so it's better structured, and like this. So, okay, we're making the first jump already, right? And then we say, okay, actually, you made the jump. If we have the same jump size than the count, that means you're landing at 0 again. P equals 0. That's it. Let's just put it up here. I feel like this is nicer to look at. That's it. P is 0. Then we say, oh, if it's 1 and minus 2 in addition, that should cover that case. So yeah, that should run. Let's try. Test case is still working. Great. Okay, we solved that algorithm. After all, it was a success rate of 96%, so I was hoping I was part of it. Thank you so much for watching. I hope you enjoyed cracking that one today. And if you want to help me out, it really helps if you hit like if you like this kind of format. It's such a small thing, but it has such a big impact. And also, if you don't want to miss out on future algorithms, you can hit subscribe. And I hope I see you tomorrow. Bye.